Hi, I'm Jordan Berg. I'm the principal investigator for the National Telehealth Technology Assessment Center. I'm also known as TTAC, and I'm speaking to you today from our lab in Anchorage, Alaska. At TTAC, we have a mission to provide independent, unbiased assessments of healthcare technology with the goal of helping to drive innovation, adoption, and best practices in healthcare and telehealth. As we navigate our healthcare artificial intelligence journey, it's essential for us to understand some of the fundamentals of artificial intelligence and how it relates to healthcare. We need to think about the methods, the system functions, and the levels of autonomy these systems use. These are key concepts to assessing risk, ensuring transparency, and making informed implementation decisions in our healthcare settings. To effectively evaluate and integrate artificial intelligence into our clinical workflows, we need to understand key types of AI systems, how they function, and what level of autonomy that they use in their decision making. Artificial intelligence processes data and generates output in different ways depending on the methodology it uses. Machine learning is artificial intelligence that learns from large data sets to recognize patterns and to make predictions. An example might be identifying anomalies in an X-ray with an AI-assisted imaging diagnostic tool. Generative AI, which is a subset of machine learning, creates new content, including text or images, synthetic data, or even videos based on learned patterns. A function might be generating radiology reports or synthetic patient data for research or training purposes. Natural language processing is artificial intelligence that understands and generates human language. A function might be an AI-powered transcription service or a chatbot that's used to assist patients in their inquiries. Computer vision is artificial intelligence that's designed to analyze and interpret visual data. A function might be a system that's designed to detect tumors in radiology scans, or a system that's used to automate lab analysis. The artificial intelligence systems operate with varying degrees of human involvement, which impacts their role in clinical decision making. We call this autonomy. Different levels of autonomy exist, and we'll start with assistive AI. So these are designed to support clinicians, but they're going to really require human oversight. An example might be an AI-powered radiology interpreter. Augmented AI is designed to enhance the clinician's decision-making, but not to replace the human input. An example might be an AI that's designed to analyze an electronic health record and find optimized workflows or trending data that may not be visible to the human eye. Autonomous AIs are designed to operate without direct involvement. An example of this being the recently FDA-cleared AIs that's designed for autonomous diabetic retinopathy screening that captures images and performs the analysis all autonomously without needing human intervention. Each AI tool's method, function, and autonomy level influences its risk profile and the considerations that healthcare teams need to include before implementation. For example, if we have a fully autonomous AI system for diagnosis, that's going to require greater regulatory and procedural scrutiny than an assistive tool. Machine learning models must be transparent about the data that they're using. That's the underlying basis for the systems. And we want this to prevent bias and to make sure that we're including a wide variety of patient populations. Predictive AI tools are going to require continuous monitoring to make sure that they're being accurate, and also that the underlying training data is going to evolve as that healthcare data evolves. If we're able to understand these fundamentals, your organization will be empowered to ask the right questions. They'll be empowered to evaluate AI solutions effectively, and they'll be empowered to ensure safe, ethical, and beneficial patient care using artificial intelligence. This bootcamp will provide knowledge and tools that you will need to implement AI confidently and responsibly in your healthcare setting. I'm going to turn this over to my next colleague who will guide you through the next steps in mastering AI adoption in telehealth. Thank you.